Hi, Ted, Dave.
Hi, Kathy called and said you'd be coming over.
Seems like your friend Van has to test out his cookie recipe.
Yes, Van has a little problem. He's trying to get a cookie that tastes good, is chewy, and he doesn't crumble. So I thought maybe if I came over here and saw the process to testing new materials, maybe there's something I could learn from this to share with Van. Do you think you could help?
I think so. Ted and I both test and analyze structures for new aerospace and space vehicles. I usually test them at room temperature, and Ted actually tests them at extreme temperatures. Since I usually test at room temperature, the components that I test are larger than those that Ted uses in his thermal structural tests. What typically happens here is the component of the vehicle structure that we're interested in is built and shipped to our labs. We then apply sensors to it to help us understand how it behaves under different loads or forces. This panel here is part of the keel or bottom section of a high-speed civil transport supersonic aircraft. This vehicle will be capable of flying at speeds up to 2.4 times the speed of sound. This panel is made from the IM7 Petty 5 composite that Kathy and Roberto talked about. This panel will be tested in tension, where we can use this machine to apply up to 1.2 million pounds of force onto the panel until it breaks or fails. While we test panels here at room temperature, Ted also does thermal structural tests of smaller panels that are usually made of the same composite material.
That's right. NASA has a research program to develop a reusable launch vehicle known as the X-33 and X-34, which we use to transport people and materials to orbit at a lower cost. In order to see how effectively adhesives and composites can work in harsh environments of space, I test relatively small samples of composite materials for liquid hydrogen propellant tanks and cyclic tests here. In one test, we use liquid nitrogen and liquid helium to cool the specimen. The panel is cooled to -423 degrees Fahrenheit, then a mechanical load is applied. An example of how cold liquid nitrogen is, we'll dip this carnation into liquid nitrogen and see how brittle the flowers become. In one test, we push materials to the max. We simultaneously subject one surface of the panel to -423 degrees Fahrenheit, while at the same time subject the other side of the panel to 250 degrees Fahrenheit. Sections of the material is then placed beneath a microscope to look for any cracks or flaws. If the flaws fall within unacceptable ranges during the time of these tests, we retest the material or even go back to the drawing board to change the fabrication process or the material.
Gentlemen, thank you so much for your time today and helping to explain to me the process of testing new materials. But now that brings me back to Van. What would you suggest Van should do with his cookies? How should he test his cookies?
Well, I think he should try a bending test performed at room temperature. That way he can see how well the cookie holds up and whether or not it crumbles.
I'll take it to extreme. You know me, Shelley. To test how well his cookie holds up, you should try a thermal dunking test. First where he dunks it in cold milk and then in hot chocolate.
Oh, those sound like some good tests. Thank you very much, and I'll report back to Van. Thanks again. And the thermal test, it went well? Great. All right, what about the bending test?
Well, I'm ready to test it now. Oh, wow, these are bending really well. I think this recipe works.
Van, I think you're forgetting the most important test.
Oh, what's that?
The taste test.
The taste test! Oh, right. Well, I'll call you back with my final results. But first, I have something planned. While I get ready for this most important test, Shelley's going back to the NASA Connect studio with some researchers who are on hand to take your phone calls and email questions about composite materials and future vehicles like the X-33. Meanwhile, I'm going to send you to Hugo A. Owens Middle School, where you'll see students from the classroom of science teacher Bernadette Smith conducting an experiment examining the strength of several materials. Follow along, and after that you'll be challenged to make your own analysis and predictions based on their results.